In this video, I'm going to explain the basics of the web, and I'm going to try to make this as elementary as possible, starting from the complete basics, and really just make the video I wish I had when I started getting into software and web app development. I'm going to go over a bunch of stuff, such as what makes up a web application, what is front-end and back-end, how does data actually travel in the web, what are APIs, URLs, HTTP, and how requests and responses work. So I know that's a lot, let's get right into it. So usually a web application is made up of two main parts, okay? We have the front end up here, and we have the back end. And the back end is usually also connected to a database that holds some data. Now, the front end is the code that runs on the client side. It's what you can see and have direct contact with when you access a web page. So this could be some text, a few buttons, the user interface where you physically see when you visit a page. Now, the back end is the code that runs on the server side, and a server is nothing more than a very powerful computer that provides services and that your personal machine can connect to using a network, for example, the internet, and ask it for stuff. So the backend handles all the operations that you can't see, like accessing and modifying the database, authenticating users, etc. Now, to make this a little bit more clear, an example of an interaction between the front end and the back end could be the following. So imagine we have a bookstore that hosts a website, and on that website you have a list of books and you can click on them to get information about a certain book. So for example, if I click on this book, I want to get some info about this book. So essentially what happens is the front end sends something called a request to the back end, essentially asking it, hey, do you have information about this book in the database? Can you show me some information I can expose to the client? And the backend retrieves that data from the database and returns it to the front end as a response, okay? And then the front end takes that info and displays it for the user to see. Okay, so I hope that interaction was clear, and I hope the difference was clear. Now, for this exchange to actually happen, the front end and the back end need to communicate, and that's where APIs come in. An API, which stands for Application Programming Interface, is nothing more than an interface that provides a set of rules for how different software components are going to communicate. It's like defining a language with a specific syntax that both the front end and the back end speak so they can understand each other. Now, in more specific terms, an API is nothing more than an interface that has a collection of endpoints and resources exposed by those endpoints. So let's go over what this means exactly. Now, an endpoint is essentially a URL, or a universal resource locator, and a resource is a piece of data that URL returns to me. So you can think of a URL as a unique address on the web that points to a specific resource, and the resource is the data you get back when you access the URL. So in my bookstore website, let me just bring it over here. So this is going to be my URL, okay, and the book with ID 1 is going to be returned to me when I access this URL, because I have books/1 right here, okay? And the resource is the book itself. It could look something like this. So we have ID is going to be 1. Then, for example, we have a title, which is going to be, something. And then we have the description, which is also going to be something. And this is going to be my resource. So this is the URL, okay, or my endpoint. And this is going to be my book resource, like so. Now, there are different architectural styles for APIs. Now, I don't know how else to explain this, but essentially if you have two houses and like one has anti-seismic construction and the other doesn't, they're both houses, but they have different architectures. They're built differently. And the same is true for APIs. So different APIs can be designed differently. They all provide access to resources, but they organize and deliver data in different ways. Now, the most important architectural style for APIs is REST. REST stands for Representational State Transfer, and it's a style of how resources are represented, how endpoints are defined, accessed, and so on. Now, RESTful systems have a couple of important characteristics that define this style. So first of all, they are stateless, okay? Now, essentially what that means is that you don't need to have information about previous requests to make a new one. They are independent. And each time the client wants to make a request, they need to provide all the information the server needs to attend to that request, because the server doesn't actually store data about the state of a client session. Now, I know this sounds not very practical, so let me give you some examples of stateful applications and then stateless applications so you can see the difference more clearly. So a stateful application could be something like a shopping cart. So imagine this is a shopping cart. I don't really know how to draw one, but essentially when you add stuff to your cart, the state of your session is updated. And the way the server remembers what's in your cart is through keeping track of the state of your cart. Now, of course, this is old school. Like modern e-commerce apps usually store your cart in a database or like send it with your request or something like that. So a more, I guess, updated example is online games, right? So when you're playing multiplayer, the server actually needs to remember stuff about you and multiplayer interactions, and even stuff like player health, position, and inventory. So these are stateful applications. REST is the opposite of that. It is stateless, okay? So going back to the bookstore example, if I ask for book 1, so if I access this resource and then I ask for book 2, like that, like the server doesn't need to remember I just asked for book 1 to give me book 2, right? Those requests are independent. So this is stateless. I hope that was clear. Now, the second thing is servers and clients communicate using Hypertext Transfer Protocol, or HTTP. I'm going to explain exactly what that means in just a moment. And lastly, data is usually represented in the JSON format in the REST architectural style. So going back to the book example I had before, so this is JSON, right? We have these curly braces to denote that this is a JSON object. Then we have a couple of properties, ID, title, and description, and then we have their values, okay? And that is REST. Now let's understand what HTTP is. We saw that endpoints are URLs that allow the front end to ask for and retrieve data from the backend, or to send data for the backend to store and update. Now, the way the data actually travels is through HTTP requests. So I'm going to write an HTTP request so I can show you what it looks like. So this is what it looks like. Now, HTTP is a protocol for how data is transferred through the web. So essentially it defines how requests and responses are formatted and what kind of data they contain. So first we have an HTTP method, okay? Now an HTTP method defines which kind of HTTP request you're making. Now HTTP methods are essentially verbs they use to determine what kind of action you want to perform. There are 4 kinds of kind of main HTTP methods. Each of them is tied to a CRUD operation. So CRUD stands for create, read, update, and delete. So for read, we have get, okay, and this is to retrieve data. For create, we have post to create new resources. For update, we have put and patch. Now I know beginners usually confuse these two, but put essentially replaces a whole resource and patch essentially just updates a part of a resource, okay? And then we have delete, which is to delete data, and the HTTP method is delete, okay? Then we have a path to a resource. And let's look at this for a second. So a path is actually different from a URL because a URL contains a couple of things. For example, when I access my own YouTube channel, this is the URL, right? Let me just grab here the black pen like that. So let's break this down. First, we have HTTPS. This is the protocol, the transfer protocol. The S stands for secure. You don't need to understand what that means exactly. Just know this has some extra security features built on top of standard HTTP, okay? Then we've got YouTube's domain name, and then finally we have the path to my channel. So the path to my channel is just /@robotmaze, okay? So if we think of this as locations, the domain name is where YouTube lives on the internet, and the path to my channel is where my channel lives on YouTube. So I hope that kind of makes sense. So the internet is like the whole world, and then the domain name is a place on the internet where a website lives, like a city, and the path is the like where a specific resource on that website is located, right? So in conjunction, they all form a full address to a resource, okay? All right, then we have the transfer protocol in its version. In this case, we have HTTP 1.1. Then we have the host API, which would be the domain name for my bookstore. And then we have a header. So this part here is the header. The header is essentially some optional information about the request, and it can contain different fields. One of them is accept, is what I have here, and it contains what type of data the front end is expecting as a response to the request. So in this case, we have text or HTML. All right, finally, we have a message body, and this contains the necessary data for the backend to process the request. For example, for updating and creating resources. So when you use post or put or delete, all of these need to have data associated about the resource so the backend can actually process the request. And the last thing I want to show you is this. So when the front end sends a request, the backend handles that request and then sends a response back with some information about how the request went. So for example, if it was handled correctly, what kind of data was altered, etc. So response is also made up of a couple of things. First of all, we have a content type in the header, and this is what kind of data was sent in the response. So this is, a parallel to the accept header in the request. Then there's a status code that tells us how the request went, and then optionally there's a response body that has some data that is returned from the server. So if we look at this example of response here, we have a status code, and then we have the content type header, and we don't have a response body. Okay, so this is actually what I wanted to show you. This table has the status codes. So first we have 200, and this is the signal that everything went fine, right? So the request was handled properly, everything went okay, everything went smoothly, 200 is returned to you. Then we have 201, which is the same as 200, so everything went fine, but this is solely for creating resources, so solely for post methods. Then we have 204, which is also great, everything went fine, but there is no content in the response body. And I don't mean this as a bad thing, like there was an error or something, simply the request wasn't asking for any information to be retrieved. There's no content, 204 is returned to you. So these are kind of the good ones, and these are the bad ones. So first of all, we have 400, and this is a bad request. So everything, something was wrong with the request, whether it is syntax, it didn't have the data that was needed, etc. So that's a bad request. Then we have 403, and this simply means that you don't have permission to mess with that resource. So to access it, update it, whatever. It's forbidden to you, so 403 is returned. Then we have 404. You probably know this one. This is the not found status code. So essentially that resource doesn't exist, or it was deleted, or you simply can't find it, and so 404 is returned to you. And then finally we have 500. This is an internal server error. So it exists to signal that something went wrong on the server side, right? Everything was fine with the request, but then the server started trying to do all the operations the request was asking for, and something went wrong. 500 is returned to you. So these are the status codes for the HTTP verbs. So get is a 200, then post is a 201, put is 200, and delete is 204. Because delete doesn't really return anything to you since you're just deleting a resource. Now the reason that put is not a 204, right? It's not a no content, is because the updated resource is actually sent to you in the response body. So, the front end can do stuff with the updated resource. And the same thing for post. So post actually returns to you the created resource. Then we have some examples of requests and responses. I'm actually not going to go over this, but I am going to put a link to this article in the description because I think it's very nice nice, very well written, very easy to understand, and you can read it if you want to, complement your learning. Okay, so I think that's all I wanted to show you today. I hope this video was helpful. I hope it was clear and easy to understand. Thank you so much for watching, and I'll see you in the next one.